Good morning, good morning. It is Dr. Murphy with Murphy Medical Associates and our team at coronatestct.com. You are watching the Murphy Medical Minute, where we are made to be well. Thanks for joining. Today I'm going to talk about a couple of things. As the news explodes after the Super Bowl and the maskless partying going on in Tampa, we are all freaked out about the variants. The variants are coming, right? We're going to explain today what the difference is between a strain and a variant. We're going to talk about the count them, four important variants. And we're going to help you understand why it's such a big deal today, based on mutations and based on what's going to happen. So, without further ado, welcome to the Murphy Medical Minute. All right, so today is February 8th, 2021. February 8th, that's the 8th, 2021. All right, and we're here today to talk a little bit about the variants, right? So what the heck is a variant? Well, first off, in case you're crawling out from underneath the rock, we're talking about the SARS-CoV-2 novel variants. You know, when we started this adventure back in March of 2020, there wasn't much talk about variants. And I think that's because it's really insider information. What? Yeah, the insiders, the people that study viruses always know that mutations happen. What's a mutation? Yes. You remember like X-Men, right? So like the X-Men, we have mutants. And those mutants can do different things. If those mutants do different things, we call it a strain, right? We call the virus that is mutated a strain. If instead just our own normal powers are enhanced, right? So if the virus's abilities are just enhanced, we call that a variant. That's basically the difference between Usain Bolt and myself, right? I was fast in high school, right? I could run, but not like Usain Bolt. Usain Bolt was abnormally fast. Could Usain Bolt fly? No. So that didn't make him a mutant in the sense of like Nightcrawler or Wolverine, right? It didn't make Usain Bolt a mutant. It made him a variant. A highly successful Jamaican Olympic variant. Right, a variant. So when we think about viruses, we think about them the same way. And so currently, we're worried a little bit about these four variants. Not four strains, four variants. Now, why the heck do we care about variants? Well, because they can do a lot of different things. They can do a lot of things more efficiently. Right? That's what we notice in variants. Now, most variants, and traditionally I will tell you, most mutations don't help a virus. Most mutations don't help a virus out, right? And as a virus replicates in our body, it accumulates mutations. Well, where does it accumulate mutations? All over the place. All over the place. It can accumulate mutations in any part of its being. But probably the biggest place that we're concerned about is the mutations found on the virus spike protein. So what I want you guys to think about with the spike protein is that the spike protein is like a hand. More like a fist, right? You can look at it here. It looks like a fist. Right? It looks like a fist. So the most important part, the part where we see mutations that are giving us problems, are in the receptor binding domain, right? That's like the inside of the hand of this little spike protein, right? This little spike protein. So if my hand gets bigger, then it can grab you, right? It can grab what we call the receptor. The receptor is located on all of our cells, right? It's located on all of our cells that get infected by the SARS-CoV-2 virus. And that receptor is called ACE2, right? So that's ACE2, deuce, deuce. So I remember ACE2. So the ACE2 receptor is on tons of our cell types. It's one of the reasons at Murphy Medical Associates and our team at ChronoTestCT.com, it's why we do blood work looking at lots of different organs, right? We look at your testicles if you're a man. We look at your ovaries and pituitary glands if you're a woman. We look at your pancreas levels. We look at your liver levels. We look at your heart levels. We look at your blood vessels. Why? We look at places where there are ACE2 receptors, because the ACE2 receptor is where the receptor binding domain, that funny little pink thing there, grabs a hold of a cell and says, get over here, right? It grabs the cell, it pulls it in, and then the virus, boop, goes into the cell and it takes over. So if you have any enhancement of your receptor binding domain, it's going to be easier to infect a cell. It's just going to be easier to infect a cell. Now, the four variants that we're looking at, where we look for mutations, the first one of these variants is called the UK variant. Ah, the British are coming! The British are coming! Ah! Yes, correct. The British are coming. And with the variant that was detected in the UK first, we've called it the UK variant. Well, everyone's worried about the danger of calling and labeling things based on where it's found, right? So we can say the following. The variant isolated in the United Kingdom in September caused a wildfire simply because it had enhanced infectivity. Well, what the heck does enhanced infectivity mean? Well, at first, believe it or not, as scientists, right, and myself, I'm a physician scientist, we assume the null hypothesis first. What's the null hypothesis? It means that there is no relation between the mutations and the infectivity and the increased transmittability. But the public health data started to show that the UK variant has increased enhanced transmissibility. So that matters, right? I mean, enhanced transmissibility matters. There's no other way around it. It means that you can give it to someone else. You can give it to someone else. Now, what's unique about it is we saw enhanced transmissibility in the UK. That's for sure. The public health has said that it's obvious data that there's increased transmissibility. Does it mean the virus has mutated and turned into, boom, a bullet? No, it hasn't turned into a bullet. But it is easier to grab the cell with, and you need less of a dose. In addition, what they found in the United Kingdom was higher viral loads, which means it was better at growing, incubating in a human. Because remember, a virus is a lot like Theon Greyjoy. What? Game of Thrones? Yes. What is dead can never die. Do you understand? A virus isn't alive. A virus needs our cells to live. So what is dead can never die. The virus is really successful at grabbing our cells and incubating, growing all sorts of more virus, right? All sorts of more virus. And so here we are specifically looking at the mutations. Now, the mutations here that matter are the mutations on the spike protein and the receptor binding domain. We also see mutations on the back side of the hand, right? The back side of the hand, maybe like this part right here, right? And that is called the N-terminal domain, the N-terminal domain. So we've got a spike protein that grabs and has a stronger fist, stronger wrist to sustain the punch. That is where these mutations are. Now in the UK variant, we see mutations predominantly in the pink part, right, in the pink part. One of these is called N501Y. N501Y. What? Okay. Put simply, that globular structure you're seeing on the screen is the spike protein. That globular structure has a bunch of amino acids, bunch of little boop, 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 amino acids all together. So you can think of every little bud on that tree there, that bud on the tree, is an amino acid. With the spike protein, there's over 1,000. There's 1,273. 1,273 to be specific for you guys, right? So that way you can really understand. Each amino acid has a number, right? It has a number on the big chain. The amino acid chain here is 1,273 amino acids. 1,273 amino acids. So when we list a mutation and call it N501Y, we say at the 501st amino acid, there is a change, an N to Y change. Could we really go through all of that stuff and talk about these and Chargaff's rule? That's a lecture for another day, guys. It's a lecture for another day. This is Murphy's Medical Minute, not Murphy's Medical Hour. So just know that those fancy letters mean that there's a mutation change. There's a mutation change. And N to Y is like what did Daniel Griffin say? It's nervous Nelly. Oh, I'm nervous about the UK variant. Well, guess what we found? When we see variants, we worry about three things. One, will the variant infect more people? Is it easier transmittable, right? Is there a change in that? The second thing we worry about, is it an increased risk of death? Like if I get variant X, is it gonna X me out, right? Am I gonna die quicker, right? So that matters. That's number two, right? Also, the big question I have is, will these variants lead to increased risk of long COVID? You know, we've got a long COVID clinic. And so the question is, will that lead to increased risk? Will it lead to increased risk? The third thing that it impacts, and that I'm also worried about, is which of these variants is going to escape? Which of these variants is going to escape vaccination? The new data today, the new science says that the AstraZeneca vaccine, the trial is being halted in South Africa. Halted in South Africa. Why? Because of the South African variant. So I want to talk a little bit about the vaccine escape here. Right? Vaccine escape is super important. When we look at the vaccines, we have to look at the data, the effectiveness with the wild type, right? And the wild type is what we call a D614G strain. So weird. I don't know what happened here. It's like the mic just died on me, right? The mic died on me. The camera died on me. So, anyways, where was I? I'm talking about the variants that can cause issues. In this case, the bigger variant that I'm worried about, the variant that I'm really worried about, is the South African variant and is also the Brazilian variant. Now, what we found with the South African variant is the following, and this is probably most concerning with the South African variant. We have found that the South African variant has escaped vaccination. The AstraZeneca vaccine is not effective for the South African variant, and so that's deeply, deeply concerning. Die out. It is literally crazy. It's like all of these mics have died out. So I'm going to go back to this because I guess that the problem we have is the audio here, right? It's the audio here. So I'm going to look back on the audio and add in additional mics. All right, so this should help. Hopefully, we should help. Hopefully, here. Let's review this slide again. Right, I'll review the slide again. Right. So here's the deal: the South African variant has no. Repeat, has no inhibition with the AstraZeneca vaccine. That's the way the science looks right now. That's the way the science looks right now. It looks like there is no inhibition. So AstraZeneca has cut the trial. AstraZeneca has cut the trial. And why did they do that? Because it is not working. They've halted the trial so they can figure out what's going on in South Africa. But currently it appears that there is minimal, if any, protection from the AstraZeneca vaccine against the South African variant, B1351, which has a mutation called E484K. So you can remember that mutation like We're going to have a problem here with the South African variant. The UK variant has increased transmissibility. The UK variant, we think, at least in England, had increased risk of harm. So increased virulence is what we call it. Virulence. I hate to use that because that's our victory sign. That's our victory sign, right? That's not for V for virulence. In addition to that, what we have is pretty interesting. What we have is a mutation that is causing significant problems, right? And that's the South African mutation. The South African mutation. I believe that the South African mutation is going to cause all sorts of problems. We found it in the United States already. We found it in the United States already. In addition, I also believe the Brazilian variant has the same mutation, E484K. That EEK mutation is going to cause vaccine escape. It's going to cause vaccine escape. That is why they had a whole bunch of people in Manaus get reinfected. And so I think the South African variant and likely the Manaus Brazilian B128 variant will cause reinfections here. You're going to cause reinfections here. So vaccine, we can debate about it at another time. Right now, I just want you to know this. Right? I want you to know this. Other than my camera going down, I got to figure out why that happened. The variants are coming. But there's an old adage in medicine. When you go to code a patient, the first pulse you should check is your own. We need to chill out here. We need to think. We need to test, treat, isolate, and trace. We need better genomic surveillance. I'm really happy with working with the Yale team and Nathan Grubau's lab. I'm also super happy working with the Wadsworth lab in New York. Right? We're in a lot of states, and we're very excited about what we're doing. I'm really happy that you guys joined the Murphy Medical Minute. I'm going to have to figure out the snafus here of why that camera kicked out, but we'll get through it. We'll get through it together, right? Welcome to the Murphy Medical Minute. Thank you all for joining. Be safe. Be good to each other. Do your best, right? Love each other. We are all in this together. Lastly, a little tidbit about Murphy's Medical Minute, and I want us all to remember this. As human beings, we are made to be well. We're made to be well. We need to take time to care for ourselves so we can be well. Right now, what we have is a pandemic of fear. We have a pandemic of fear. And fear is not going to help anyone. Fear is not going to help anyone. You know, so little can be achieved when you're afraid. Right? You talk to Master Yoda. Fear leads to anger, anger to hate, hate to suffering. We don't need fear. We just need to take care of each other. That's all. Remember, this is Dr. Murphy, Murphy Medical Associates. You've watched the Murphy Medical Minute. Take care of yourself. And remember, you are made to be well.